Good day, my amazing scientists. It's your favorite sensei here again, Sensei Mha, and I hope you all are doing good. I am also doing good. If you are on today's lesson, we will be dealing with a past paper on electric circuits. So we'll be dealing with this today. And if you have not yet subscribed, please do the right thing. Please subscribe to our channel. And welcome to the club. So don't forget to press that like button, comment in the comment section, share the video as much as you can to your friends, to your neighbors, to your cousins, and tell them that Sensei is back with a fresh lesson. We are dealing with electric circuits. So let's begin. So now we have a question here. It says a battery with an unknown EMF and negligible internal resistance is connected to 4. So it has an unknown EMF and an unknown, it doesn't have internal resistance, since they said it's negligible internal resistance. Connected to 4 resistors, a high resistance voltmeter, and 2 switches, 2 ammeter, and of negligible resistance, as shown. So now let's start. So before we tackle this question, firstly, I usually tell all my students that before dealing with a question, you have to first check, okay, we have this A2 here. We know that this A2, we will use this A2 to find the total ammeter reading, the total current. We will use that A2, which means here we know let's just draw it. The current will flow from this terminal through here, so which means here it's A total that will be passing there, and here we know that it will divide. This will be first current, the second current, it will divide since they are in parallel, and then after that, which means that the same current that passes through, that is recorded at ammeter reading 1, it's the same one that will pass through A2, the 2 ohm resistor and 5 ohm resistor at switch 1, and then after it will reconnect again. So now they said now both switch S1 and S2 are closed, so which means the current is passing through here. Ammeter A1 reading is 1.2. Calculate the voltmeter reading. What do we know about the resistors in parallel? Remember, these two, the 2 and 5 are in series to each other, and this is parallel. Both of them are parallel to this 3 ohm resistor. So it's more or less like this. Let's just draw it again. It's R, and here we have 7. We have that 7 1, and here we have the 3. So we know that the potential difference in this, it's the same. Potential difference in parallel is the same. So which means the voltmeter reading on V is the same voltmeter reading on this one. So which means if here we have our current and we have the resistance, we can find the voltmeter reading, which will be the same one from here to here. So let's tackle question 1. So it's V parallel, it's I times R. So we can just use this path here, the path on A1, I2. Let's just say I2, because we know that the same resistance, the resistance will be the same here and here. So it's 1.2 multiplied by 7. So it's going to it gives us 6.4 volts. Ne? So this 6.4 volts is the same, so 8.4 volts here and on both of this. Ne? Whenever they are like, since they are in series to each other. Ne? Just remember that. So let's take a look at the second question. They find the reading on A2. Where is A2? Oh, this one. Ne? So find the reading on A2, which means we have to find the total current. So which means we know that the total current is the current on the first current plus the second current. So which means it will be this current passing through here and the current passing through here. And now we already know the current that passes through here. We can find the current that passes through here because we also know the resistance and the voltmeter reading. Ne? So let's try finding the reading on I1, ne? The first current. I1 equals to V over R. So it's 8.4 divided by 3. 8.4 divided by 3, it's 2,8. Ne? 2,8 amperes. So we know that it's 2,8 plus 1,2. It will give us 4 amperes. Ne? It gives us 4 amperes. Ne? So remember how we found this answer. They're looking for this resistance, the total current here, which we know that the total current is the current on A2. And we know here that in parallel, this current that passes through here and here, they will divide, which means it's this one, but it divides into these two parts. We already know this one. We can find this one because we can find this one here because now we know the voltage and the resistance. So we can just manually find that and add them together. They will give us the total current. Ne? So let's go to the third question. Find the power dissipated. The power is, you know, the thing. The formula is IR squared. Ne? So the power dissipated at 3 ohm resistor, so which is this one. Ne? So we can either use this I because of we have found it. So if you didn't find the thing here, ne? You can use another equation. So you can either use this one, ne? I'm just doing this delete 2 because of, let's say for example you were struggling with this one and now it will be very hard for you to find this one. So rather you use the resistance and the voltage, ne? The potential difference, which is 8.4 to the power 2 over 3. Then we find it in the calculator. It will be the same answer. It will be similar to this one. Here we'll have 1.2. Let's see. Okay, so 2.8 squared multiplied by 3. Ne? Let's test. See, it's the same answer. No, even if you use the current to the power 2 and R, just remember here that you are using the current that we found here, ne? The current on I1, which is this one. Ne? Just make sure you're using the correct current, because if you use a current that is not correct, then your answer will be different. So just please make sure you use the correct one, because of you using the current that passes through the 3 ohm resistor here. Ne? So you see, it's the same whether we use the P V squared over R or I squared times R. The answer is still the same. Ne? So let's do everything now on a new page and erase. Ne? So now here they are looking for the EMF. But then now the question says S1 is now opened, which is this one, ne? I'm just gonna use a white one here and just erase here. Ne? It's black and just do this, ne? Show that it's open. While switch 1 remains, switch 2 remains closed, which means this is closed, this is open. So now, what do we know about this instance? So we know that in this way, current will no longer be passing through here. Okay? It will no longer be passing through here. We know that now current will only pass through here only. Ne? Why? Even though you all may say, but say it's open here, even if by virtue of it being open, which means that current cannot pass and wait here, remember, it can't happen. So by virtue of this switch being opened, which means that there won't be any resistance passing through here. Ne? So now, which means that the total current, it will be the very same current that passes through here. So now, which means that the total current from ammeter reading 2, ne, is the total current. It will pass through here, ne, and here and here and here, ne. It will be the total current passing through the same thing. And remember again, this and this are not in parallel to each other. They are not in parallel, ne. So R, resistor R, and 3 ohm resistor are not in parallel to each other, ne. So please don't make that mistake and say that they are parallel, ne? Because of, remember, we can't say they are parallel because of they are divided by this. There's a cell, the battery inside, in between. Unlike here, you can see whether they are in parallel to each other, ne? So, which means we know that, even though they didn't give us this, ne? So now that since we don't know what is the voltage here, ne? So 3 ohm resistor, the reading on A2, the reading on A2 is 3.48 amperes, ne? So which means that this is the total current that will pass through R, ne? And it will be the same current that will pass through the 3 ohm resistor. So now, since we don't have this, which means that we have to do it simultaneously. We have to do equation 1 and equation 2. So many of you may wonder, equation 1, which one will be equation 1? So we'll be doing this, comparing the volt, since we know that the EMF in a battery is the same, ne? EMF is the same, because of it's the same battery, they didn't change the battery, which means EMF is the same. Which means EMF on the first instance, this one, ne, will still be the same EMF on the second instance, ne? So here we know that the EMF is the V external plus the V internal. But here we don't have V internal because they told us we don't have any internal resistance here. So which is the V external is the V parallel plus the V in series, ne? Which will be, this will be our equation 1. So let's try solving it, ne? So we still don't know what the EMF is. EMF equals to the V parallel, which is V parallel here. So we need to find the parallel, the total parallel. So firstly we know that it's this one, it's the voltage on the 3 ohm resistor. I'm just gonna do this, plus the voltage on the parallel. Remember this one is series, ne? It's in series, this one. So we know our I total in the previous was 4, and then from here, it was 4 amperes, ne? So now we know that this is the voltage on V parallel and V series, ne? So we knew and get from the previous question on 8.2.2 that the total ammeter reading and the total current in the circuit is and get 4. We know that in series there's current is the same. So let's try to find the total resistance in parallel. So let's use this equation. Since this one's a series to each other, so I'm gonna add them. So it's 7 plus 1 over 3. It will give us 1 over 7 plus 1 over 3. It gives us 10 over 21. 10 over 21 equals to 1 over R parallel. Then we know that we're going to cross multiply here, and the R parallel is 10 over 21, which is just 2,1. This is the total resistance in parallel. So now let's try redrawing this. So we know it's going to be this, the R. This is the battery, and here we will have the resistance in series. This one will be the resistance in parallel, which is 2,1 ohms. So it will be like this. So now we know that the current is the same. So we know that it's okay. So here it's this I T, which is 4 ampere. So it's we know that ampere V according to Ohm's law it's I times R. So it's it's 4. Sorry about that. So it's 4 multiplied by R plus V parallel, which is 2,1 multiplied by 8.4. Remember, this is the resistance. Sorry, it's the sorry about that. This is the it's 8.4 that we found in the previous. So it's this. Remember, where does this come from? It is just 2,1 multiplied by 4. This one is the total resistance in parallel multiplied by this total current. It's just this one. It's the same one as this one that we found here, which is the voltage in parallel. So this is our EMF on the first equation. So we understand this. So now let's try finding our EMF on the second equation, which is this one. Even though it may be a little bit tricky, but it's more or less the same. So we know that here now in this instance, we just know that it's R here. Sorry, I should have made it a rectangle. And switch on 3 ohm resistor. So we know that here both are in series. There's no resistance in parallel here. So you know that EMF here on the side, it's V parallel plus V series. Okay. Even though we don't have this one, it's the V on the 3 ohm resistor and the V on this one, on R and on the 3 ohm resistor. So here we still don't know. Even though we know that the total current is 3.4, it's just 3,48 multiplied by R, because of we don't know the resistance on this one. Yet on this one we know that it's 3 multiplied by 3.48. So let's just punch this in the calculator and find the answer. So of equation 2, let's just simplify it. It's 3 times 3,48, which is 10,44 plus 10,44. So this is the second equation. So now we have the first equation, we have the second equation. So from here now we just do it simultaneously. How and why? Ne? Because now we know that the EMF is the same throughout the circuit, ne? Because of the battery is the same, EMF really doesn't change, ne? So it's this V, this equation 1 equals to equation 2. So ne, it's gonna be this R plus 10,44 equals to 4R plus 8.4. Ne? So let's just choose a side. Let's take everything that side and this to the other side. Ne? So we are doing solve for X now, but we're solving for R, ne? Before. Then after that we will substitute the R that we found and substitute it in one of these equations to find the EMF. So it's 4R minus 3,48 R, and here is 10,44 minus 8.4. Let's punch it in the calculator. It's 2,04 here, and here we have 0,52 R. Ne? So we just divide both sides by this. Divide by this. Ne? 2,04 divide by 0,52. In our answer we will find that R equals to 3,92 ne? 3,92 ohms. Ne? So we can just simplify it and just make it just a 4 ohm resistor. Ne? Even though I don't really support this, but then let's just leave it in this way. It's this multiplied by 3,48 multiplied by 3,48. It's 13.65. 13.65 ne? Plus 10,44 ne? Plus 10,44, it will give us 24,08 ne? Volts ne? So yeah, if probably they said that we should just leave this answer in just the whole number, since it's the voltage, we will just say it's 24 volts. Ne? So this is how we do this type of question. So remember, what's the first step that we did? Let me erase everything here so that you will not be confused. So remember, the first thing here ne, is that we know that EMF is the same throughout the battery. So since we do not have resistor R in both instances, ne, so we're gonna find the equation of the we're gonna try to find the EMF on the first one, ne, which even though it will leave this one as an unknown, ne, it will be an unknown because of now we do not have the resistance on series, this one, ne? So it will just be an unknown, and also in the second instance it will still be the same unknown. So then from there on we just equate this and do simultaneous equation. So from there on, after we found the resistor ne, and then we just substitute it in one of these equations and we find the answer. So it was really nice doing this lesson with you, my amazing scientists, and I hope you all enjoyed the lesson too. Again, don't forget to like, to subscribe, press that like button down there below, and that notification bell so whenever we post new lessons you'll be updated. So from me, your favorite sensei, it's a wrap, and we out. Peace and love. Bye bye.